In this video, we're going to be looking at the F distributions and one-way ANOVA. We're going to interpret the F probability distribution as the number of groups and sample sizes change. We're going to discuss two uses for the F distribution, which is a one-way ANOVA, that's what we are going to be doing, and the test for two variances, which we won't do in this class. We're going to conduct and interpret a one-way ANOVA. We're going to conduct and interpret a hypothesis test for two variants. Actually, we won't in this class. We're only going to be doing the one-way ANOVA. For hypothesis tests, we are going to be looking at the averages between two or more groups. Now, we have done two groups, so that was in Chapter 10. Now we're going to be doing more than two groups. And statisticians have developed a method called analysis of variance, abbreviated ANOVA. Although ANOVA was going to use variances in the computation, this is a statistical approach for determining whether or not the means of more than two populations are equal. The one-way ANOVA is used with data categorized with one treatment or factor, which is characteristic that allows us to distinguish between different populations from another. So in order to us to be able to do the ANOVA test, there are 5 basic assumptions that must be met. Each population from which the sample is taken is assumed to be normal. So the populations are assumed to be normal. All samples are randomly selected and independent. The populations are assumed to have equal standard deviations or variances. The factor that we are looking at is a categorical variable, and the response is a numerical variable. Our hypothesis test, like in the end of Chapter 12, is going to be similar. The means of the populations are equals, or they're not. So we have in Chapter 12, we said rho is equal to 0 or rho is not. So that's where we are here. The conclusion is to reject our null hypothesis, which means the means are not equal. Fail to reject, of course, means that the means are equal. The F distribution is a standardized statistic that measures the extent to which differences among groups means exceeds that may be expected by a chance model. The F statistic is a ratio. There are two sets of degrees of freedom, one for the numerator and one for the denominator. For example, if F follows an F distribution and the number of degrees of freedom for the numerator is 4, the number of degrees of freedom for the denominator is 10, then it would be noted this way: an F distribution 4, 10. We are going to use Excel. There's really great equations. They're in the book. Any book, your statistics book that covers this is in there. We are going to use Excel because it's awesomely quick and easy. You just have to understand what's coming out. So in your Excel, you may need to do an add-in called the Analysis Tool Pack, or you can use your graphing calculator. So if you look in the book, there's the steps on how to do the F statistic with your graphing calculator, T83 or 84. So here's my example. 4 basketball teams took a random sample of players regarding how high each player can jump in inches. The results are shown in the table below. So I'm actually going to jump right to what I put into Excel. So to get to the statistics, you're going to click on data. Then you're going to click on data analysis right here in the toolbar up top. This is where if you don't see this, you're probably going to need to do that add-in. Once you do that, you should have a pop-up that does this and says, hey, what do you want me to do? You want to choose the ANOVA single factor, and you're going to click OK. Then this is going to pop up. You're going to put in everything that is in that table. Now you're going to enter the highlighted cells for the data you are completing the test on. Okay, so all of the cells. You're going to look to see how your cells are grouped. Are they grouped by columns or rows? Mine are grouped by columns. Choose the labels in the first row. I chose that, and here's my alpha. So I'm going to put those in. And I have an output range. Now what this is I'm just going to click anywhere on the spreadsheet that doesn't have information on it. So I'm telling the Excel spreadsheet where to put my answers. Now, here's a couple things you need to note. When you pick your data for the input range, you will either need to add a blank row above the data, or you will need to include the titles above the data. Otherwise, it will treat your first row of data as the column titles. So just a little caveat of note. So this is what comes out. all this information. Here's the count. Here's the sums. Here's the averages. Here's your variances. What we care about is this F statistic, the p-value, and the critical value. Now we can see that this F statistic from up above is between the 0 and this critical value. So it's fallen in the area where we are going to fail to reject the null hypothesis. But my p-value also tells me that too. So if I go back up, and now I can start filling all this in, what is my F statistic? By my spreadsheet, I got 2.060393. The critical value, that was the 3.47805. What is the p-value? That was the 0.161351888. Lastly, at the 5% significance level, is there a difference in the mean jump heights among the teams? And since we're going to fail to reject the null hypothesis, there is not enough evidence to show there is a significant difference in the heights of the jumps of the players among the teams. And that's it for this quarter. That's it for this video. Thank you for joining me, and wherever life takes you, good luck.